Today I will discuss some topic related to strain gauge. I have quite bit to cover, so let uh, divine in. First, let's understand what strain gauge is. Strain is the amount of deformation experienced by a body in the direction of the applied force. So when I apply force on an object, we look at how its dimension changes, and that's what we call strain. Let's get into it. The formula here is divide. Uh, 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 Here is the formula. You can say is del L by L divided by the initial. Here the formula here is divided the small changes divided by the initial dimension of the body. So we indicate and we indicate strain. So if I talk about the change in length, that is del L, let's call it delta L or del L, and the divide it by the total length, that is L. So that is the formula for strain. Now strain comes in two types, one in tensile and other is compressive. It's a super simple. Pull a body, applying a force to stretch it and increase its length, we call that tensile. So I am trying to shorten it, and when we do that with the strain, we call it compressive strain. So there are actually two types of this. It's a ratio, so it doesn't have specific dimension, but if we need to indicate it, we can use millimeters or inches. So in practice, this strain is usually very small, which is why we measure it in microstrain, like in the range of 10 to the power of minus 6. Now let's see how it works. A strain gauge is basically a simple type of resistor that we attach in the form of a wire. So the idea is that it converts mechanical motion into an electrical signal. We use this resistor to turn it into an electronic signal. Here we have a wire that arranged in specific patterns. This is the wire, specific um, uh, pattern, and as its length increase, the resistance also goes up. We choose a longer wire for this reason, so that the resistance is higher here. So these two terminal just function like resistance terminal. We connect this to the wire like this, meaning we shoulder it. So we will call this shoulder tanks, as indicates here. Okay. Now this gauge generally measure the strain in just one direction. So look at the length of it here. This direction is what we actually call the gauge length. Now gauge length. Now this gauge generally measure the in sorry so you can also write this down. The direction of the gauge length is aligned with the skin direction right here, like that. Okay. In this case, I can only measure in the horizontal direction, not vertically. This is the horizontal direction. So in that direction, it will remain sensitive. This strain gauge is also called bonded gauge, because whatever strain we need to measure, like if I want to measure the strain on a metal pipe, I will stick it to that. So I will use blue tape. uh, so I used to blue tape here uh, to attach it. So it's called bounded because we are bounding it together like that. Okay, that is why referred to as a bounded gauge. So that is the gauge length I have got. So I have already mentioned that this is called gauge length, which we generally measure in formula, in our formula. So look at this. All the forces all the forces acting here with affect the register what remains on the sensor register. As I mentioned before, this will remain insensitive, so no register will change here. However, if I apply force in the direction of this horizontal length or direction of x, the resistance will change here. There are two types. One is tensile and the other is compressive. As I said earlier, tensile means if I pull it, the length here will increase. The strain has a gauge length, and if that gauge length increases, the resistance here will also go up. So the other hand, if I compress it, like pressing it down and reducing its length, the resistance here will the value of the resistance will decrease. Okay, this is the property we are using in our work. But before we get into that, we let's look at the types of um, strings. Okay, as I mentioned before, it has two terminals, and we use it for the state measurement in one direction. But if I need to measure multiple direction, I would typically use two or more strings. Okay, when we are measuring two direction in the train, I can do it with the biaxial Rogers method. Okay, just hold. Okay, so biaxial Rogers, if we are measuring three direction, then I can use three elements or a shear pattern. The number of connecting wires, it can also change. Okay, um, can also change along with the number of direction. Now let's move on the working part. Here we will focus on the measuring circuit. So our train gauge is just a register. It is simple wire that has some register when a train is applied. After a change happens here, if we need to measure the change in resistance, we use to a bridge circuit. Okay, this is a bridge circuit involving the bridge circuit. In this, we look at both balanced and unbalanced condition. The balanced and unbalanced condition help us in output measurement using R1, R2, R3, which are fixed type resistor, meaning their resistance stay constant. On the other hand, R4, which we indicated as the strain gauge, as a variable resistor that changes based on strain. Or okay, so as soon as I apply the strain here, okay, the resistance will changes. Now look at how this strain is working. First, let's check out the balance condition. The balance condition involves two resistance, which are R1 and R2. Those R1 and R2, those are balanced. Okay, and um, the balance condition involves resistance which are R1, R2, and then we have another pair R3 or R4. If the ratio between these two sets balanced and unbalanced of resistance, then we will get this value of ratio is equal. Then we can call this a balanced bridge. And when it's balanced, the current going through here and the current going through there will be equal. So if the current are equal, so there will be potential difference here, and in that case the output voltage, so in that case the potential difference is here. So there will be a potential difference here, and that case the output voltage will be 0. That means this portion output voltage V0 equals to 0. However, if the circuit becomes unbalanced, meaning the ratio are not equal, and the output voltage will no longer be 0. So when everything is normal, we are not applying any strain here, and we will keep the ratio in such a way that the output voltage stay at 0. But once we apply strain, the resistance will changes, because we already know that the R1, R2, R3 are constant, but R4 who changes within the applied strain. So if we are not applying any strain, and we'll keep the ratio in such a way that the output voltage stay at 0. Okay, so but once we apply strain, the resistance will change, and that will affect the overall output. So basically what we are saying is that will get a non-zero output here. If the resistance is lower, the current will flow in one direction. If the resistance is higher, it will flow in the opposite direction. Okay, this change gives us an unbalanced bridge, which result in some output voltage. That's exactly what we need to do. We had to convert it into an electrical signal, and that's what we have done here. This is a way we can calculate the strain, and the formula will be here. You can see that V0 is equal to V0 equals to R3 by R3 plus R4 minus R2 by R1 plus R2 into VEX. Okay, and the gauge factor equals to you can see here gauge factor is equal to del R by R equals to del L by L. Okay, I have mentioned before is how we measure strain. So using this unbalanced bridge, we can calculate whether the strain is compressive or tensile. Now let's look at the advantage and disadvantage of strain gauge. They are small and don't have moving part, which means they are not prone to wear and tear. They are very precise and accurate, require less maintenance, and are inexpensive. So those are the advantage. Now let's move on the look at the disadvantage of the strain. It only measures strain in one direction. If I need multiple measurement, I have to use more than one strain gauge. Also, it's sensitive to temperature changes because it's made of conductor. So we know that when the temperature changes, the resistance also changes, plus it needs regular calibration. Now let's see the application software cases where motion is involved and forces is being applied to the metal. In those cases we need a strain gauge. So when you use the gauge, it will be applied in load cell for wing brakes, scale, vehicles, medical and educational application. It will be monitor structure, bridges, building, helping to identify if a passenger is small one, meaning a child, or if they are an adult. So beside that, we can also use it in railway tracks. Feel free to move on. So that is the application of the strain gauge in load cell.